Hi everybody, Captain Al speaking for FTD number 6 brief today. Hope everybody is doing well. Okay, the lesson overview is a flight from Boeing Field, no different there, but we do go to somewhere different, Spokane, in the Boeing world. The overview of this lesson is that the non-normal procedures are introduced. We have some route modifications, speed and altitude changes, so all those are review. Navigational practice. Today we do introduce the missed approach, and then we do an ILS approach to an autoland, and then shutdown procedures. The lesson objectives for number 6 would be we're going to practice flight deck preparation. Well, kinda. Again, we've cut out most of the flight deck preparation because we did that in lessons 1, 2, and 3. And then we've abbreviated from then. But we will pick it up on this lesson. We'll pick it up right at the engine start because we do have an engine start problem. So I'll have the airplane powered up, and we will assume that we have done the whole procedure up to the point where we're going to start engines. And then we'll take the rest of it from there. We'll do a speed and altitude restrictions and constraints again. That's no different. I think we've done that already. We do start to create some waypoints in this lesson. I think up till now we've created the along track waypoint, which is a created waypoint. So this time will be a couple of different ones. Place bearing distance is the one primarily, but we'll discuss place bearing, latitude, longitude waypoints, and other created waypoints besides just place bearing distance. There are a couple of non-normals because we introduced non-normals on this lesson, but I'm going to change those because we ended up on, I think it's the month, it was the February, I believe. February bonus videos are on electrical, and there is one on electrical non-normals in flight. And that would cover the 2 non-normals we're doing in this lesson, which would be electrical, which would be the generator off procedure and the generator drive procedure. And those are really covered in those bonus videos, so no sense in doing those on FTD number 6. We'll pick a couple of other ones besides electrical. We'll do a route offset, deviation around weather, by using a route offset. We'll do a cruise climb, which you've already done. We'll change our cruise speed, which you've already done. Again, this is in form of review. And then here's another created waypoint, the airway crossing fix. We'll create one of those. And then a cruise descent, which we did last week as well. And then in for the ILS approach. But in this case, we're not going to see anything at minimum, so we'll do a missed approach, and then we come back around for radar vectors for the ILS approach to an autoland, and then shutdown procedures. Lesson 6 will be at Boeing Field. Bravo 4 will be the gate, although we're not going to be there. But yeah, we will be there because we'll be starting engines. So we'll be at Bravo 4. Runway 32 left is the departure runway. The route of flight, Seattle J20 Yakima, Yankee Kilo Mike, direct ropes, direct Spokane, Gulf Echo Gulf. The SID will be when we add it for during the clearance, it'll be the Needle 1 departure, direct to RADI flight plan route. Destination is Spokane, Kilo, Gulf Echo Gulf. Sonic 44 will be our call sign. We'll still be in pounds. We'll be in pounds, and we'll be a freighter. So zero fuel weight, planned zero fuel weight will be 480,000 pounds. Fuel on board, 150,000 pounds. Gross weight, 630,000 pounds. Again, when you fly this, if you want to use kilos, feel free to do so. They're on the right side. Reserves 20,000 pounds, cost index 120, cruise altitude will be 250. We'll be using TO1 thrust, fixed D rate, and climb 1. Be a flap 10 takeoff. We're still using NADP 2. Acceleration height 1,000, engine out acceleration height 1,000, thrust reduction flaps 5. the wind's at 340 at 12 knots. Slope is 0 and the CG 25%. Preliminary, and then we'll update it with the final, which really won't change. You'll notice on the right side there we have some cruise winds, and that's for when we discuss the waypoint wind page. We'll put in 3 of those winds, cruise wind at the Yakima for 17,000, flight level 210, and flight level 250. And then the ATIS will be information Foxtrot, 340, 12 knots, 15 statute miles. Broken skies at 2,500 feet, temperature 15, dew point 10 Celsius, altimeter 29904, departing runway 32 left, and the information will be Foxtrot. Our clearance, when we get it, in this case we will have already gotten it since we're starting with the engine start. But it'll be cleared to Spokane via runway 32 left, Needle 1 departure, direct RADI, flight plan route, climb maintain flight level 250, cross RADI at 17,000, Seattle departure will be 126.5, and squawk 4416. So we'll have a restriction there to cross RADI at 17,000. Top altitude will be flight level 250. Then on lesson 6, here are the items we're going to cover. We will do a non-normal engine start. We'll have a problem, and we will still be using auto start. I think one of the lessons we do a manual start with the auto start inoperative, but in this particular lesson the auto start is operative. We'll have some sort of a problem that will lead to the auto start shutting down the engine. We've done some altitude restrictions and constraints, and we'll continue with those, removing them or adding them. We'll enter speed and altitude restrictions, again, on the departure. We'll have a created waypoint as we depart, which will be a place-bearing distance. And then we'll have a non-normal. I think on the non-normals, again, we'll skip the electrical because that's in month 2 bonus. So I think we'll do maybe an outflow valve problem, something that's not that involved, and maybe like a pack message to that we have a pack problem, maybe a pack overheat or something like that. So we'll do an air conditioning pressurization one more than electrical. So again, just note that the electricals will be replaced by air conditioning and pressurization non-normal. Then we get an offset due to whatever, and we'll say weather. They want us to offset our route. And during the offset, we'll do a cruise climb. We'll change our cruise speed. I think this time we'll probably do it through the CDU. I think last time we did it through the mode control panel via speed intervention. And but again, we can do the same thing through the CDU if we choose to. And then again, number 9 there would be the air conditioning pressurization non-normal. And again, if you haven't seen the electrical, go watch month 2 bonus videos on the electrical non-normal in flight. Then we do an airway crossing fix. That's another created waypoint we can do. We'll resume normal speed. Then we look at, I think we look at another EFIS ICAS control panel, but I think we've discussed that, but we'll do it quickly for review. Then we do a cruise descent. The arrival set up for the ILS 21 at Spokane. On the way in, we'll have a smoke, fire, or fumes problem, leading to the checklist for smoke, fire, or fumes, and or removal if it calls for that. And then we'll descend into Spokane. And we're going to do the ILS 21 with a transition just like we did last week. So I think we do the ILS 21 probably with a Spokane transition, Gulf Echo Gulf transition. And then we do the full procedure. And then on the way in, at decision altitude, we don't see anything, so we do a missed approach. We'll carry out the missed approach procedure with the emphasis on the procedure. And then we get radar vectors back around for the ILS 21. And then this is what it looks like on the map. We'll come out on the needle 1 departure. We'll be cleared direct to RADI at some point. And then from, of course, the magenta line is our planned routing. The yellow line is our what we actually do. And so you can see after RADI, we're going to go to that place bearing distance, the Yakima 23015 DME fix. And then after that, it'll probably be direct Pendleton, Papa Delta Tango. You can see we do an offset as we're going from RADI to that Yakima 23015 fix. We go J16 to intercept J153 to Spokane. That's a modification. And then we're into Spokane for the approach. Full procedure leading to a missed approach, back around for radar vectors to probably Sigyo, and then in for the ILS 21 approach. So that's what it looks like on the map. Again, magenta, or purple if you want to call it that. It's not really magenta, it's purple. Purple would be the planned route, and the yellow is the what we actually fly. Okay, so the company routes are something that I don't know that too many people have them anymore. There may be some airlines that have them still, but it used to be early on they had more company routes, and they found that company routes took up too much space in the database, and so we ended up getting rid of them. And you had to enter everything manually. Or today, you know, a lot of times you can just request your routing from your dispatch, and then they will send it via uplink, and you'll get it automatically. So, but in the past, you know, you didn't have that ability to uplink company routes and performance information and stuff like that. So they would load company routes into the database, and then you could select those company routes, and then automatically it was kind of like an uplink, but it was stored somewhere. And what they found is ATC, you know, would change the routing too much, that the company routes would have to be modified quite a bit, and so it kind of defeated the purpose for company routes. So they, and plus the space in the database, they didn't want to take up. They felt it was taking up too much space. But if an airline does have company routes, if they're a smaller airline, they might have them and program them in there. And then they'll have some kind of identifier that would identify that company route from, in this case, from Boeing Field to Spokane. So in this case, our identifier was FOGTO3. And then when you put that into the company route line, and you'll notice it's a dashed line. A dashed line means that it's optional entry. You don't have to enter something in a dashed line if you don't want to. It's not required. But in this case, if you want to get company route, you'll put it in the dashed line. So in this case, we put it in the R3 position. And when you do, that'll create the company route for you. It'll include the origin, the destination on page 1, and then the main part of the routing on page 2, which in this case is Seattle, J20 Yakima, direct ropes. We're not going to do that because I don't have any company routes. You'll notice it does not include the runway. It does not include a SID or a transition to a SID. So you'd have to still put those in, but it does include the main routing. And then you could activate execute, and then you still have to put your runway in and any SID or transition. Today we do have a thrust limit D rate. So we're going to use TO1. Usually airlines can specify what they want for TO1 and TO2. Those would be fixed D rates. It could be, I think in the case of my Aerowinks, I think I can change it in Aerowinks as well, but right now I think it's set to 5% and 15%. In this case, it's 10 and 20%, so airlines can kind of specify what they want for that fixed D rate. And of course, the default is always going to be your full takeoff thrust and full climb thrust. And then you have to select whether you want a fixed D rate or an assumed temperature D rate or a combination of both. So TO1 would give you a fixed D rate of 10% less than the full rated max thrust. And TO2 would give you 20% less than the full rated max thrust. And of course, there would be performance charts for the fixed D rates. So you could determine whether you could use them or not, or your dispatch would determine it and they would give you what the performance is. But normally we'll have charts to back that up. If we don't get it from dispatch, we could always figure it out ourselves. And normally when you select TO1 or TO2, you're going to arm climb 1 and climb 2, which are fixed, which are also fixed climb D rates as well. And you're not limited to that. You could always change, like if you wanted to select TO1 thrust, but you wanted full climb thrust instead of climb 1, you could just select climb and it would change. You're not locked into climb 1 thrust. You could always go to climb thrust if you wanted it. So you'll see here when we select TO1, TO1 selected, and climb 1 is armed. Now, of course, there is a limit to how much you can derate. You can only derate down to 25% less than full rated thrust. So you can't derate below that. You've got a choice here, you know, whether, depending on the airline, you could be using fixed D rates, you could be using assumed temperature method, or you could be using a combination of both. The assumed temperature method would use the selected line here to pretend that the temperature is warmer than it actually is to reduce the thrust. And of course, reducing the thrust based on your weight helps the engine life. So if you were to take off at full takeoff and full climb all the time, there would be a lot of wear and tear on the engine. So where we can, obviously, we reduce the thrust if the weight allows it in order to save those engines, because they're expensive engines. And they want them to last as long as they can before they have to overhaul the engine. So in many cases, we'll use these D rates, whether it be fixed or assumed temperature or a combination of both. So you'll notice here, if I'm going to go ahead and delete this. Again, this is how the default would be, just like it looks right now. TO selected, full climb selected. Now the outside air temperature is listed at the top. Your takeoff N1 is listed on the right side there at R1. And in our case, for the AeroWinks, we're using 5% for TO1. That'd be 5% less than the max rated thrust. And then TO2 would be 15% less than the max rated thrust. Again, you'll notice if you select TO1, climb 1 will arm, but you can change it to climb if you don't want climb 1. Or if you had some kind of obstacle requirement that you don't use climb 1, you use climb, then you can change it from climb 1 to climb, and then climb would be armed. If you go to TO2, again, it'll arm TO2 thrust and climb 2 thrust. But again, if you don't want that, you can always change it to whatever climb thrust you want. If we use the assumed temperature method, then we're using a temperature that's much higher than it actually is, so we can reduce the thrust based on the temperature as long as it's okay with the weight. So if I put in, let's put in 48 degrees Celsius, we're pretending that the temperature is actually 48 Celsius and not 15 Celsius. So by doing so, and that takes way too long. Again, in the airplane that would take, or the simulator would be a lot quicker than that. You'll notice when you put the assumed temperature in, then it's going to use full TO thrust, but with that assumed temperature of 48. And in this case, it arms climb 2. Now what it does is it looks at the fact that you've put in that temperature, 48 Celsius, and it kind of says, okay, based on 48 Celsius, that thrust reduction is somewhere greater than 15% less than full rated thrust. If it were to arm climb, that of course would be full climb thrust. If it were to arm, and that's anything less than 5%. So if you put a temperature in here that was less than 5% of reduction of max rated thrust, it would arm climb. So, you know, if I put maybe something like 22 in there, let's see what that does. That takes way too long. See, in this case, it arms climb, because it's saying, okay, it's only you've only reduced by 5% or less, or actually less than 5% of the rated thrust. If I were to put, let's say, 33 in there, yeah, that's way too long. Yeah, then it would arm climb 1. And so that's saying that it's somewhere between 5 and 15% less than full rated thrust. So we know it's somewhere in between there. We don't know where exactly, but it's somewhere between 5 and 15%. And then if you put a temperature of, like, let's say we put 52 in here, now we know it's going to arm climb 2. And that would mean that it's greater than 15% of reduction of the max rated thrust down to a maximum of 25 degrees, or 25% of full rated thrust, not degrees. So depending on what you put in here as far as temperature goes, it'll either arm climb or climb 1 or climb 2, and climb would be less than 5% reduction. Climb 1 would be between 5 and 15% reduction, and climb 2 would be between 15 and 25% reduction, and you can't reduce more than 25%, won't let you. So even if you put some temperature here that's really high, it's still only going to reduce up to 25%. Now you can also use, again, depending on the airline, you'd have to have the performance and charts for this, and obviously your dispatch or performance engineering would need to be able to figure this out. But you can use a fixed D rate, like let's say we use TO1, but we also add an assumed temperature to it. You could do that as well. And again, you can see here that it still arms climb 1, which means the thrust is somewhere between 5 and 15% reduction. It's going to be more than 5%, but less than 15% with that temperature in there. If you put 52 in here, then you can see it arms climb 2, because we're selecting TO1, which is a fixed 5%, but then we put that assumed temperature in there. So again, depending on the airline, some airlines will use just fixed D rates, some airlines will use just assumed temperature, some airlines will use a combination of both. It just depends. There are some restrictions that, and you can find this in the adverse weather section under the contaminants, where if you're using assumed temperature, it can differ from using fixed D rates. And if you're interested, go read that. I won't go into that right now. But there are some restrictions on what you can do if you're a fixed D rate versus an assumed temperature. Entering waypoint winds. If you have to manually enter these, and again, we talked about that you could request these from your dispatch, and if they have the capability to uplink your route, uplink your performance, they can also uplink all the winds. And all you have to do is basically push a button, and and confirm, and it uplinks everything. But if you have to enter them manually, there's off of the legs page, there's a route data prompt. And again, the caret means if you push that, you'll get the route data page. So if we go ahead and push that, we will get the active Route 1 data page. And on that page, it's the same as the legs page as far as waypoints goes, but what changes is here. You've got ETA to the waypoints, you've got fuel remaining to the waypoints. So if you remember last week, we talked about using the progress page to get the ETA and the fuel remaining at waypoints along your route. and then it would say en route waypoint. Well, this is another way to get it. You could go to the legs page and go to route data, and then you'd have the ETA right here for ropes, for example, and you'd have the fuel remaining at ropes. But on this route data page, you can also get to the waypoint wind page, and each waypoint will have a waypoint wind page, and again, it's telling you if you want that page, select the caret. So we're going to put in winds for Yakima, and again, that's on the flight plan. So we could go push the caret here, which will give us the waypoint wind page for Yakima. And it'll come up blank here, and it'll have dashes for altitude. And then, of course, you can put in the winds that you were given on the flight plan. Now, these are a little bit different winds that were on the flight plan, I notice. But you first put an altitude. We would have first put 170 for 17,000. Line selected that to the altitude line. It would put in 17,000, and then you'd have dashes over here. And then you could put in 310/25 and line selected to R4, and then it would put in that wind. So then you'd have that altitude and that wind. And then you can put in the next one, 210 for flight level 210, line selected to the altitude line. That'll bring up flight level 210, and then this will be dashes over here. And then you put in the winds for flight level 210, which would be 330 at 35. And of course, this is all in your paperwork. Your paperwork would have all this information as far as winds go for each of the waypoints. Again, you can see this can get kind of tedious. If you enter up to you can enter up to 4 altitudes and 4 winds, depending on what your cruise altitude is and whether you plan to step and things like that. By putting in waypoint winds, you're basically refining the ETA and the fuel remaining at destination. Because, obviously this airplane goes long distance, and the IRSs are looking at where you are right now, and they can kind of project out for about 300 miles based on the winds that you have. But we know that if we fly a long distance, the winds are going to change. And so obviously a long flight compared to a short flight will be vastly different in your ETA and fuel remaining if you don't put in waypoint winds. So to obviously give an accurate picture of going from point A to point B, especially when it's international long haul, you have to have these waypoint winds in there. Otherwise your ETA and fuels won't be very accurate. So based on, again, our paperwork, or based on getting it from dispatch via an uplink, we can put in these waypoint winds. And in this lesson, we'll have them put in. Actually, they'll be put in already, won't they? But when you do this yourself, when you fly this profile yourself, go ahead and put these winds in just for to see how it works. And once you put any wind in, whether it be 1, 2, 3, or 4, and then you go back to the route data page, you'll notice there's a W, and the W would mean that it's pilot entered winds. So we have entered 3 altitudes and 3 winds at Yakima, so it'll have a W next to it, indicating that we've entered something for Yakima for the waypoint winds. Now, if you have to enter these manually, I think like we talked about before, you can always enter enough to kind of get you to cruise altitude or a little beyond that. And then once you're up and away, then it would be usually the pilot monitoring's job to start putting in those winds for the all the way to your top of descent point. And then that way, it helps refine that ETA and fuel remaining at your destination. You'll notice now if we go to the ropes waypoint next, we have the waypoint pilot entered wind at Yakima, but now we're going to go to the next waypoint, which is ropes. So we're going to push the R4 button here, and then that'll take us to the ropes waypoint wind page. And you'll notice that those altitudes will propagate down. So they're in there because you put them in there at Yakima. But these winds will be in small font now because they're the winds that propagate forward from the Yakima winds that we put in. Now, if we don't want that, obviously, and we want the ropes, we can look at our paperwork and say, okay, the ropes wind at 17,000 is 33065, or at flight level 250, it looks like this would be. The actual winds are 33065, or forecast winds. That ropes are going to be 33065. So we can update that and type out 330/65, and then line select it, in this case at flight level 250, and then that'll go big font. And then those winds are going to propagate forward to the next waypoint, and the waypoint after that, and the waypoint after that, and the waypoint after that. So you can change, all your waypoint winds going from waypoint to waypoint. Now, you don't necessarily have to change them all, but you have to have a good representation of the winds for your route of flight. And obviously, the more you put in, the more accurate the ETA and the fuel remaining are going to be at destination. You'll notice again that these are small font because these winds are being propagated from Yakima. But we've changed it for ropes. So this is the new forecast wind, and now that is going to propagate forward to the next waypoint and so forth. You can also put in a altitude and outside air temperature like they have here. They put in 190/-5, and that would be a known temperature for the altitude that you're at. And then it will figure out the outside air temperature for these particular altitudes based on a standard lapse rate of 2 degrees centigrade per 1,000 feet. So it has no way of knowing if it's not standard, but it's a little better information than having nothing. So if you know that there's a particular altitude that you're at and you look at the temperature, you could put that outside air temperature in there, and then it would figure out the temperatures for these altitudes based on 2 degrees centigrade per 1,000 feet. You'll notice that flight level 17,000 here is 2,000 feet below 19,000, and so that'd be a 4-degree difference, and so it figures out that that's -1 at 17,000 feet, which is 4 degrees difference based on that 2 degrees per 1,000 feet. And then we'll see, because we put in the wind at ropes, we're going to get a W that it's a pilot entered wind at ropes too. Again, it doesn't take, it only takes one to give you the W, but you could enter all 4 altitudes and 4 winds at ropes if you choose to do so. And that's normally what we do. We normally put in the 4 altitudes that are in your paperwork and 4 winds. But again, it makes it so much easier when you can just uplink all this and boom, it's in there, and it's great. Okay, we're going to look at non-normals, or we start to introduce non-normals today. So you may have heard me talk about this before, but there's 4 indexes in the quick reference handbook, the QRH, for the 747. There's a quick action index, an ICAS message index, an unenunciated index, and the alphabetical index. So there's 4 of these indexes right at the beginning of the QRH. And of course, on the top of the QRH is the quick action index. And these consist of the items that are required to be done in a very timely manner. They may or may not have memory items associated with them. Some do, some don't on this page. You'll also notice the font is different. The cabin altitude's in bigger font than engine 1, 2, 3, 4 auto start. Evacuation is in bigger font. IAS disagrees in bigger font. The rapid depressurization, the smoke, fire, fumes are in big font. Actually, the IAS disagree doesn't look like it's big font. It's just all caps. So anything that's bigger could be an item that you might be wearing smoke goggles. And they make it a little bigger just so it's easier to see if you were in a smoke-filled situation. So they make the font a little bit bigger if you were in a cabin altitude situation where the flight deck was fogging over and you're trying to read a checklist. Evacuation, same thing. You might be on with goggles on, or with the oxygen smoke hood all in one unit on your face. Same thing with rapid depressurization or smoke, fire, fumes. Depending on where the smoke, fire, fumes are, you might be on oxygen. So they make those bigger font than the smaller font. And then again, you'll notice some are in all caps and some are not in all caps. And generally the ones that are in all capital letters would be the ICAS messages. So cabin altitude is an ICAS message. Rapid depressurization, notice it's not all in caps. So, that's not an ICAS message. That would be an unenunciated message. But normally, if we get the trigger of cabin altitude, then we're going to initiate a emergency descent. You'll notice smoke, fire, fumes is not in all capital letters. It's not an ICAS message. We just know that we may smell smoke. We may see smoke, we may smell fumes, we may have a fire on board, in which case you don't necessarily get an ICAS message for that. So that would be an unenunciated. But anything where you see all caps, it would be a ICAS message, like IAS disagree, that's all caps. Engine 1, 2, 3, 4 auto start, all capital letters, so that's an ICAS message. But the multiple engine flame out or stall, not an ICAS message. We just know we have multiple engines that are stalling or flaming out. So that's the quick action index. And again, some, like we said, will have memory items, some will not. Evacuation, for example, is not a memory item. We just turn the book over and the evacuation checklist is on the back. Fire APU, no memory items for that. But fire engine 1, 2, 3, 4, that has memory items. So you can't tell from this what's a memory item and what's not. Cabin altitude, we have memory items for that. Aborted engine start or auto start, we have memory items for that. Or engine 1, 2, 3, 4 fail, we have memory items for that. But some of these we don't. Fire engine tailpipe, there's no memory items. But again, these are the items that need to be handled in a quick and efficient manner, so they're put on the front of the QRH. And if it does have a memory item, we're going to do the memory item first, and then we're going to come to the QRH and then go to the procedure, and then carry out the rest of the procedure below the memory items. The other, right behind it, is the ICAS message index. And like we said, this is all caps. This is all capital letters. And that indicates that it's an ICAS message. So any ICAS message that we get, we can really just go to this section, which is right behind the quick action index, and look it up in alphabetical order. You'll notice some have carets and some do not. A caret would indicate it's crew information only, and it'll list what it is, what it means, but there are no procedural steps for the crew to take out. There's not a procedure 1, 2, 3, 4, 5. There's nothing listed for that. It'll just describe what it is. It's kind of crew awareness or a crew notification and what it means, but there's no actual checklist procedure to do on that particular item. But the ones that do not have a caret would be ones that have procedural items that we have to carry out as a non-normal. Then right behind that, again, that'll go in alphabetical order all the way to Z. And then behind that will be the unenunciated index. You'll notice these are not capital letters. So these will be things that don't have an ICAS message associated with them. If we have a fuel leak, it doesn't necessarily tell us there's a fuel leak. If we have to dump fuel, it doesn't necessarily tell us to dump fuel. If the flight controls are jammed, there's not necessarily an ICAS message with that. If we can't bring the landing gear lever up, there's not necessarily an ICAS message with that. There will be eventually a gear disagree, but if the gear won't move up, then that would fall under unenunciated. If we have two engines out, there's no ICAS message that tells us go to the two engine out inoperative landing procedure. It's an unenunciated item. And so on the next page, you would see the two engine inoperative landing procedure in the unenunciated section. So again, these are items that are not covered by an ICAS message, but that you would go to in the event of these particular problems. And then behind that would be the alphabetical index. And this would include everything. So everything's here. Quick action items, ICAS messages, unenunciated messages. Everything's here. It's in alphabetical order. So if you're not sure where to go, this would be the checklist to go to, because that's going to be the checklist that gives you everything, all items. We are going to have an auto start problem, and remember the auto start will give us a message after it can't start the engine, and it pretty much covers most items in the 747-400, but it doesn't cover oil pressure if there's no oil pressure, and it doesn't cover if N1 is not rotating. So we obviously will monitor that on the start. We want to see oil pressure. We want to see N1 rotating. But if for some reason it did not, that's not going to be, the auto start system is not going to be triggered for those conditions. So if we didn't have the oil pressure increasing, then we would do the aborted engine start checklist, which does have a memory item associated with it, which is the same as the memory item in the auto start procedure. And that is to bring the fuel control switch for the affected engine, whether it be number 1, 2, 3, or 4, to cutoff. And so that's why we have aborted engine start checklists, even if we have an auto start airplane, because auto start doesn't monitor everything. It does monitor, a hot start, a hung start, a no light off. It's monitoring a lot, but it doesn't monitor N1 or oil pressure. And so we would have to take action via the aborted engine start procedure, which includes the same memory item you see here. And then we go to that checklist instead of the engine auto start checklist if we had no N1 or no oil pressure. But in the case of a hot start or a hung start or something like that, the EEC and the auto start system will attempt to correct the problem. And for the GE engines, it'll try 3 times to correct the problem. So if you had a hot start, it would stop the start, it would motor the engine, and then it would try it again. And probably do some things like reduce the fuel flow or try what it can to make it a good start. If it can't do it the second time on the GE engines, again, it would stop the start, it would motor it, it would do whatever it needs to do to try to do a good start on the third one, maybe reduce fuel even more, and then attempt a third start. If it can't do it the third time, it says, okay, I've tried. And at that point, you'll get the ICAS message, engine 3 auto start. And once we see that message, we would take action to identify the ICAS message, engine 3 auto start, okay, memory item, fuel control switch number 3, cutoff. And then the captain would bring the fuel control switch to cutoff. It doesn't need to be verified because you're on the ground. So it's not a verified item that needs to be verified by the other pilot. If you got the wrong one, it's not critical at that point. But so it's not a verifiable item or that needs to be confirmed from the other guy or gal. If it's a hung start, Again, it'll kind of do the same thing. It'll try to adjust if it can and try to restart the engine. And if it doesn't work, it doesn't work. And you'll get the message. Pratt & Whitney engines for auto start would try it twice. The GE's, it's 3 times and then it stops. The Pratt, it's twice. If that has an auto start system on it, it's twice and then it would stop the start. Let's take a look at this. So if we got an engine auto start message, we would again identify it. Let's say it's engine 1 auto start. So we'd identify it, engine 1 auto start, and then we do the memory item. Fuel control switch number 1, cut off. Engine auto start 1 checklist. That's basically what we do. And then we would go to the engine auto start checklist. Engine 1, 2, 3, 4 auto start. And this is for 109. Here it is for 570. Again, you want to make sure you get the freighter. 570 in this QRH is the freighter, and the 109 would be a passenger airplane. So you notice the condition is during a ground start, one of the following conditions occurs. Auto start did not start the engine. The fuel control switch is in run at low engine RPM with the auto start switch off. The objective is to shut down the engine and motor it. So fuel control switch number 1, cut off. And we would have already done that because that's the memory item. Anything above the dashed line below it is a memory item, anything above it. Anything below it are the procedural steps after you do the memory item. So in this case, we go fuel control switch number 1, cut off. We'd still read it if the FO is doing this. And the captain had called for the checklist. He would still read this, but that's been done. And then it would be choose one. And anytime you see a diamond like this, a diamond, it's a decision point. It's either one or the other. So the engine start light is illuminated or the engine start light is extinguished. Which is it? If the engine start light is illuminated, then we're going to motor the engine for 30 seconds. And then after 30 seconds, we're going to bring the engine start switch. We're going to push and stop the start. And it basically just motors it in that case to clear the engine out, the fuel out, and things like that by motoring it. And then after 30 seconds, we'll stop the start. And then from there, we would get maintenance, because obviously the auto start system tried to start it. It tried 3 times. It couldn't start it. We stopped the start. We motored it because it was illuminated for 30 seconds. We stopped the start. Now what do? We get maintenance because we don't know what the problem is. So they need to check into it. And you'll notice again the boxes indicate that that's the end of the procedure. And that's what we'd say, end of auto start number 1 checklist, or just end of procedure, end of checklist, whatever you can say, to denote that it's the end. And of course, if this is the case where the engine start light is illuminated, I guess you're seeing my pointer. If the engine start light is extinguished, we're going to go to step 3. So step 3 would say when the N2 decreases below 20%, then bring the auto start switch off, and this will allow engine motoring. You always make sure you read notes. You always make sure you read notes before you do it. So even though this says auto start switch off, I'm not going to go right up and push the auto start switch off until I read the note. This allows engine motoring. Okay, that makes sense. So now I'll go turn it off. Engine start switch pull. Motor the engine for 30 seconds. And then after 30 seconds, engine start switch push. So we're doing the same thing. We're motoring the engine, but in this case, because the engine start light was extinguished, we had to bring the auto start switch off and pull. It may be pulled already, but it says engine start switch pull. You're just making sure it's pulled. It's probably pulled already, but you're going to go up there and pull it anyway. And you should see the white starter light. And then again, we're going to motor for 30 seconds. And after 30 seconds, we're going to push. And that would be the end of the procedure, end of checklist. And then again, we'd get maintenance at that point. And that would be the end of the procedure. We will do some manual starts. I forget which lesson it's on, but we'll assume that the auto start is inoperative, and we'll do a manual start. And I think we do it in the FTD. I know we do it in the full flight, but I think it's in the FTD as well. If not, we'll add it. We talked about low altitude level offs. I think maybe we'll probably do one this time. So we'll amend that clearance to maintain 2,000. And then after that, we'll be, once we're cleared from 2,000, we'll be cleared up to flight level 250 to cross RADI at 17,000. So we'll add the maintain 2,000 on takeoff. Maybe the tower will add that and give us an amended clearance when we're ready to take off to maintain 2,000. We'll set 2,000 in the MCP, and then we'll take off. And again, as we said, it's not a big deal in this airplane. We talked about that once it captures that 1,000 feet, or 2,000 feet in this case, once it captures that 2,000, even if you're not at your acceleration height yet, the airplane will start accelerating at that point. In this case, the engine, the acceleration height is 1,000 feet, so at 1,000 feet it should start accelerating. So it depends on our vertical rate. If our vertical rate's really high, it may capture this earlier than 1,000, in which case it'll start the acceleration process at that time. If you were to level off at 2,000, you're going to get one of two indications, either VNAV path or VNAV altitude. In our case, we're going to get VNAV alt because this will be a MCP intermediate level off, because there's not going to be anything in the CDU that says maintain 2,000 feet at this waypoint. If you had something in the CDU, a restriction, and you had 2,000 in the window here, and you had 2,000 in the CDU, then it would say VNAV path, like you see here. And in this case, you can see on the ND, we have at the Seattle 02 waypoint, we have a 2,000 foot restriction in there. You can see it right there on the ND. This SID is not the SID we're flying, by the way. This is this used to be a SID. It was actually a Boeing SID. It was, in other words, it was make-believe. It was a Boeing SID out of Boeing Field called the Quiet One. And it was a database, Boeing database SID, basically, that you could pull up. And it was for training purposes only, just to be able to pull up a SID out of Boeing Field. In this case, this particular model that I'm on here, I forget what it is, but I had to build the waypoints because the Quiet One's not in here. So I had to build, you can see Seattle 02, 05, 06, 07, things like that. And these would be the created waypoints as we go. But in our case here, we did have a restriction at 2,000 feet, and that's why it says VNAV path here. In our case, you're going to see that we don't have a 2,000 foot restriction on the legs page, so it's going to come up into VNAV alt, not VNAV path, indicating it's an intermediate level off through the mode control panel, and it's not a constraint through the CDU, which would be VNAV path. And then we'll accelerate and retract flaps, and then we'll be cleared out at 2,000 feet. You'll notice here that when we passed Seattle 02, remember that had a 2,000 foot restriction in there? And again, this is not our SID, but we'll discuss the point of this. If we pass the waypoint that had the 2,000 foot restriction, and we haven't set a higher altitude in the MCP, it's going to go from VNAV path to VNAV alt, because it's not going to violate this. So if you haven't set a higher altitude and you cross this waypoint, that VNAV path will change to VNAV alt. And then the next waypoint that has a restriction, which in this case is at Seattle 07, we have 8,000 feet. To cross this waypoint at 8,000 feet, that would be the next waypoint constraint. So if we did this, if we were busy and we crossed this waypoint, it goes into VNAV alt, and now we're cleared, up to flight level 250, we could spin the window to 250, push the selector, it would come out of VNAV out and go to VNAV speed. And then we continue the climb to cross Seattle 07 at 8,000. And again, if we were cleared unrestricted to flight level 250, then we could simply, again, do the things we talked about. And I think we're going to review those, which is climb direct or delete, or push the selector to delete the restriction. We've talked about all that. So this is just demonstrating that we crossed the Seattle 02, but we didn't set a higher altitude in the MCP window. Maybe because we're busy and it's a low altitude and ATC's talking to us. But now if we are cleared up to a higher altitude, we can spin that higher altitude and we can push the selector and it'll go into VNAV speed. And it will not delete a restriction in that case because you're coming out of VNAV out to VNAV speed. If you push it again, it'll delete a restriction. But that first push is just going to be to get you out of VNAV out and put you into VNAV speed and resume the climb. And then if you wanted to delete this 8,000 feet, you could do it with pushing the selector. And if that's the last one, then we would climb to flight level 250 unrestricted, if that's what we were cleared to. And you see here they're talking about that. So you're climb to flight level 250 unrestricted. And again, we talked about that there's a couple different ways you can do that. And one is deleting on the climb page. If you remember, we talked about that. So you could have the pilot monitoring, delete the altitude, delete the 8,000 foot restriction, and he could do that on the climb page. He probably wouldn't because he'd probably be on the legs page. I could do it on the climb page, but I'm not going to do that because I'm at a low altitude, and I'm not going to be sitting there fooling around the CDU on the climb page. So this would be something the pilot monitoring would do, or you could do through the mode control panel by pushing the selector, and that would also delete the restriction. So this is the first way, just to delete off of the climb page, which we probably wouldn't do because this guy would be on the legs page, and why would he go to the climb page to delete that? He can delete it on the legs page. The other way would just be on the legs page like we are here. This would be the more probable method of the FO, if he's the pilot monitoring, to push delete. Delete comes up in the scratch pad, and then you can delete here at R3. That would be the more probable way. And then, of course, another way would be to use climb direct if you want to wipe out all altitude restrictions between you but not including the MCP altitude window. And so again, would I do this? No, not at this altitude. I wouldn't do it. So I wouldn't be fiddling around with this climb page unless I'm above 10,000. Then I can do that. I can manipulate the climb page, but I'm not going to do it when I'm below 10,000. So, but I could do it up here. So again, I could push the selector number 4, and of course that would remove the 8,000 foot restriction. And now you can see we've got another restriction at RADI at 220. Ours is going to be 17,000 for what we have, but it must have been a long time ago. It must have been 220. And you'd have to push it again then a second time to get rid of that if you were unrestricted. So again, those 4 methods, you've got to remove restrictions. Delete it on the climb page, delete it on the legs page, use climb direct, or use the selector. And that's going to be the pilot flying that's going to use a selector. And again, if you're on the legs page, the easiest way is delete it on the legs page. If you're the pilot flying, you can delete from here if you choose to do that. You'd want to verbalize that to the pilot monitoring so he knows what you're doing. Or, again, if you're again, if I'm going to use climb direct, it's going to be the pilot monitoring that's going to use that unless I'm above 10,000. And you can see when you remove all restrictions go away, and the climb direct prompt goes away. So you can see here we went climb direct, this goes away, this goes away. Or if we, again, if I deleted one of them, but there's another restriction, then that restriction would still be here. And the climb direct would still be here. So until you wipe out all your restrictions up to but not including that MCP window, then you'll get blank here. Blank, climb direct goes away, it's blank, and the altitude restriction is blank. Then we're going to have some kind of speed restriction. We probably won't do this one again. We'll probably do something a little higher, maybe to maintain 280 knots till passing 15,000 and then resume normal speed. We'll do something like that. We did this one last time to 230 below 10. We'll do something a little higher. But again, if you want to put a restriction in, again, there's a couple different ways we could do this. We could do it through the mode control panel, just opening the window. Open speed window. Dial the speed back to whatever we're cleared, whatever the ATC wants us to do. In this case, let's say it's 280 above 10,000. And then when we get through 15,000, we could then push the selector and resume normal speed up on the mode control panel. That's one way. But we're going to do it through the CDU. So if we were told to maintain speed 280 till passing 15,000, let's modify that, then we would put in 280/150 and line select that into the speed restriction line. And when you do that, it would have 280/150,000, but the speed up to 10,000 will be 250 up to 10,000. So that's going to be obeyed first, and we're at a weight that allows 250. Could be higher than this if the weight is higher, right? And if it's significantly higher, you'd want to advise departure that you need a high-speed climb on the departure, since you're limited to 250 below 10 in most cases, or in the States, certainly in most countries too. So in this case, it'll maintain 250 to 10, but then it will go to 280. It's not going to go to your econ speed. It's going to go to 280 until 15,000. And then once it passes that, this will go to dashes, and the speed will go to econ. Its speed transition, 250 to 10, this is going to blank out once you get to above 10,000 feet. So we'll modify this to do 280 up to passing 15,000. Now there's the other way you can do it, speed intervention. So you could open the window, and when you open the window, it'll go to your target speed, and then you can select whatever speed you want. And then when you're told to resume normal speed, then you would blank the window. And that's kind of the way we did it when we did the 230 knots. We opened the window, we brought the speed back to 230. So this lesson, we're going to do it through the CDU. We'll do 280 to 15,000. And then, of course, when you pass 10,000, like we just talked about, this is going to go blank. The speed transition line will go blank. This is deletable, by the way, so that if, there's some countries that will, you could request that you want high speed because you're going over the ocean maybe. You're taking off from an island and you're going over the ocean, and if you request a high-speed climb, they can give it to you, and you can delete that speed transition, and it'll go right to econ. So that's not going to happen in the States, but there's some countries where you could request a high-speed climb when you're below 10,000 feet, and then you could delete that speed transition. Then we're going to get a route modification after RADI. We're cleared direct to the Yakima 23015 DME fix. And so that's a created waypoint. And we put it in just like it sounds. Yakima, Yankee Kilo Mike, 230, we type out 230, and then there's a slash between the place bearing and the distance. So the format that the computer understands is place, bearing, slash, distance. So when we put it in the scratch pad, it would look like this. Yankee Kilo Mike 230/15. And where does he want us to do that? After RADI. So we put it after RADI. And when you do, it'll create a 5-character identifier. And in this case, it calls it the Yakima 08 because we had 7 created waypoints before that. And that was because I created all those waypoints on that Quiet One departure. So that's why it's calling it Yakima 08. In our case, it'll probably call it Yakima 01 because it'll be the first created waypoint in Route 1. And so it goes in there as a 5-character identifier. And if you're not sure what that is, you could always line select it back to the scratch pad, and it'll come back to the scratch pad as a place, bearing, distance, but it'll be in tenths of a degree and tenths of a mile. So it'll say Yakima 230.0/015.0. So it just comes back down, not quite like this, but in tenths of a degree and in tenths of a mile. So in this case, we would execute that, confirming with the pilot flying. How do you like that? There's the Yakima 23015. And again, I'd look at it and kind of see if it makes sense. Okay, here's Yakima, and we're going out this way, and it's about 230. There's the 180 here. 230, and it's about 15 miles here. I just kind of want to make a reasonableness check to make sure that kind of makes sense when I look at it on my map. So after RADI, direct to the Yakima 23015 DME fix, and we would go ahead and execute that. And then after that, we're going to be cleared direct to Pendleton, direct Spokane, so that'd be all one clearance. After RADI, cleared the Yakima 23015 DME fix, direct Pendleton, direct Spokane. So we would put that in. We put in this, the Yakima 23015, then Pendleton, then Spokane. There's a route discontinuity, and then on page 2, there would be the unwanted route, which is still there. And then, like we said, you could take whatever that unwanted route is, it may be multiple waypoints, and take the last route waypoint, bring it to the scratch pad, bring it back to page 1, put it in the boxes, and then delete one waypoint. So it looks like there's there's not that many waypoints, but yeah, it looks like we had to bypass some waypoints here. So we probably went to page 2 and found a couple of other waypoints besides ropes. Now, ropes was the last route waypoint, so we brought it to the scratch pad, went back to page 1, put it after Spokane, and then deleted that one waypoint, and then execute. And that'll get rid of all the unwanted segment. So you can see now by me executing it, I get rid of all the stuff that was here, that was going from here to here. And now we've got RADI, Yakima 01, it'll be in our case, more than likely, and then Pendleton, and then Spokane. And then we execute that. Non-normal. Okay, this is the electrical generator off. You can see that this is a very easy procedure, right? You just reach up there and read the checklist, obviously, generate a control switch, whatever it is, off and then on. And again, on month 2, if you haven't watched that video, watch that on the electrical in-flight non-normal procedures, and that'll have all these 2 that are covered on this lesson. And we'll go to the ICAS message list, which is right here. And let's say we have an outflow valve left message. So we're going to go to the O's. Now we can see we have outflow valve left and right. We have outflow valve left. It's in section 2.21. So we would turn to that in the book. In our case, we can it's linked. So you can push and go to the outflow valve left, right. Condition, one of these occurs. Automatic outflow valve control is inoperative, and the outflow valve manual switch is on. In our case, it'll be that the outflow valve control is inoperative, the automatic. The objective is to control the cabin altitude manually. So then it says outflow valve manual switch left. Again, we don't say affected value. We say what it is, left or right. What is it? Outflow valve manual switch left, on. So we'd go ahead and turn the manual switch to auto, and we're going to bring it to on, which is pushed in. It's an alternate action switch. And then pack control selector 1, pack off, doesn't matter which one. If I have a choice, it's going to be 2 or 3. So again, 1 pack off, for me it would be either 2 or 3 and not 1. And the reason for that is because 1 never shuts down for anything. 2 or 3 can shut down for various conditions, like an overpressurization. Pack 2 can shut down. With a cargo fire, packs 2 and 3 shut down. There's things that will cause packs 2 or 3 or both to shut down. But number 1 never shuts down for anything. So that's the one. If I have a choice, I'm going to leave that one on. So in this case, I'd probably turn off 2 or 3. And then it says outflow valve manual control, push to close, and hold until the outflow valve indications show fully closed. So you're in manual on the one side. The right side's on automatic. The left outflow valve is manually controlled now. So you can use the little toggle switch, and we'll show you this in the FTD if you don't know what I'm talking about. We'll toggle that outflow valve closed. And the airplane can operate just fine with 1 outflow valve in automatic, and that other one just fully closed and out of the picture, basically. And notice that's the end of the procedure. There's nothing else to do. So the auto system failed. We went to manual. We closed that outflow valve. We turned 1 pack off because there's only 1 outflow valve, and it'd be a little too much airflow for not having 2 outflow valves. But with 2 packs on and 1 outflow valve open, it's fine. It'll operate just like normally. So we'll do that procedure for the one, for this one right here, for that, the electrical generator off. We'll substitute that with the outflow valve left. Then the next thing that we do is we offset left or right of course. We'll say for weather, because maybe there's a thunderstorm directly in front of us, small cell or something, or maybe ATC just wants better spacing and they request. They know these airplanes, nowadays they know these airplanes can offset. It used to be early on they didn't know that, and so you'd have to request an offset, and they'd be, they wouldn't necessarily know what an offset was, but they know these airplanes all can offset off your course. And obviously you can request a heading as well to if you wanted to deviate around weather. And we'd probably do that more with a heading. But we can offset our course left or right, of course, and it'll parallel our route. And you can offset up to 99 nautical miles. And the format for putting that in is to put an L or an R followed by the distance. If you do it the other way, it would say invalid entry. So if you put in 15L, it would say invalid entry. If you put L15, it'll take that. And where do you find route offset? You find it on the route page. So anytime you hear offset route, offset your route, it's a route offset. It's on the route page where you find it. That's the easy way to remember it. And you'll notice the offset prompt is down here at the R6 position. You have the offset prompt. It's got a dashed green line, which means you don't have to put something in there, but if you want to offset, you do. So it is kind of a required entry if you want to offset, but you only offset if you have to. So we can put something in there. And we're going to put in L15 in this case. I should mention one thing here. If you're on a SID or a star with a SID transition or a star transition, or maybe it doesn't have a transition, doesn't matter. So any SID or star transition, you're not going to see the offset prompt down here. So you can't offset off of a SID or a SID transition or a star transition. This offset's not going to be displayed here. And you'll wonder why, normally they're not going to give you an offset probably on a SID or a star. And if they did, you could still do it, but you'd have to use heading select. And then you could use your cross-track error on the progress page 2 to do that. But if you try to offset on a SID or a star, you can't because the offset is not there. But once you're past that waypoint that defines the SID transition, then the offset will appear. That's when it pops up. Boop. Once you pass the waypoint, it'll pop up. So normally this is reserved for non-SIDs or stars. You know, it's when you're in your route segment, basically, that you can offset left or right, of course, up to 99 nautical miles. So we're going to go ahead and put that in. And when you put that in, it goes in. And it is an executable item, so you'll kind of verify it with the pilot flying, and he'll say, there's the offset 15 miles left of course. Do you like it? Yeah, I like it. Execute. Notice on the ND, you have a white dashed line that goes off your route 15 miles. It's a modification, so it's white dashes, and it follows your route all the way around here because it's offset 15 miles to the left. Once you execute that, it'll become a series of long dashes and short dashes. Long dash, short dash, long dash, short dash, and it'll turn from white to magenta, indicating it's active. The airplane, if it's in LNAV, will automatically start to turn to go to that offset, and it'll intercept it at about a 45-degree angle. And so it'll fly along here until it gets, within whatever its capture logic is here, and then it'll turn and follow that dashed magenta line, long dashes and short dashes. Now, a technique is that if you're up high and you're doing this and you've got passengers, a lot of times it's a smoother operation to go to heading select first, spin the heading bug off to your left, then put the offset in. L15 and execute. How's that look? Looks good, execute. And then arm LNAV. It's a smoother turn for the passengers. LNAV uses its own logic to make the turn. And so if you're at your cruise altitude, it can go up to 30 degrees of bank. And it can be kind of abrupt if you were to do this at 36,000 feet. And you're going to offset some mileage left or right, of course, and you leave it in LNAV. So a technique is we go to heading select, spin the heading bug off, put the offset in, and then rearm LNAV. Again, not necessary to do that, but it's for passengers, it's a smoother turn. It's less of a turn. It's going to go 15 degrees instead of, kind of cranking over it, maybe 25 or 30 degrees. And then while we're doing this, we'll be, intercepting that offset. We'll get a cruise climb to 270. So same thing here. We just spin up the window to 270 from 250. We push the selector. It replaces our cruise altitude of 250 with 270. The title of the VNAV page changes from Active Econ Cruise to Active Econ Cruise Climb, and we climb to 27,000 at our cruise airspeed. And you can see we came out of speed VNAV path to thrust ref VNAV speed. The thrust will go to back to climb thrust when we're doing this, and then when we level off at our cruise altitude, we'll go back to speed VNAV path, and then our thrust will change to cruise on our primary ICAS. Unless you have an airplane that stays in climb. Some airplanes, some airlines will elect to not have the cruise reference, but just have the climb all the time. In which case it wouldn't change to cruise when you get to your cruise altitude. I think the way I have the arrow links is it does change to cruise. Now to delete the offset, once you're cleared back on course, disregard the offset, resume normal navigation. There's 3 ways we can do it. One way is to just delete it. So you can push delete. Delete would come in the scratch pad, and then you can line select that to the R6 line, and that will delete it. That will get rid of it, and then you'll have to execute it. The other way would be you could enter 0 in the scratch pad, and line select that to the offset line and execute. That would be another way. So you can delete or you can enter 0. And the third way would be to just, if you're cleared, you might be on an offset. We'll say we're clear of that weather. We can resume normal nav now. And then he says, okay, yeah, just go present position XYZ. Okay, that'll remove the offset as well. So you can go direct to a waypoint, and that removes the offset by going direct and executing it. You notice if we have the offset in there that the offset light is illuminated on the CDU as well, both CDUs. That's just kind of telling you you're on an offset route. Same thing goes here. You may want to, before you execute it, you may want to go to heading select, fly the airplane, put a 45-degree intercept in, and then execute. And then the airplane will turn smoothly then and not go, not crank it over hard to 30 degrees or so if you have passengers. If you're a freighter, you probably don't care. But now anytime you delete or anytime you enter 0, it's going to come up with all zeros. That's what it'll look like. It just say 0, 0, 0, and then you execute it. And like I said, before you execute it, you might want to go to heading select if you're on a passenger airplane. Turn it, then execute. And that removes the offset. So you can see then the airplane, if it was an LNAV, it's going to stay an LNAV. And the offset line is removed. The airplane will fly back to the course and then resume the normal navigation at that point. And notice the offset line is still on the route page, but it's in dashes again, ready for you to put in an offset. Then we're going to reduce the speed to 290 knots. And so I think the last time we did this, we did it through the MCP. This time we're going to do it through the CDU. So we can take the 290 speed and we can line select it into the econ speed line. And when you do that, it'll say selected speed and it'll be a modified econ cruise page. And then when you execute it, this will go back to active 290 knot cruise, I believe it says. Let's see if they show us that. No, they didn't show it. But it'll say active 290 cruise. And then you'll notice that when that's in there, after you execute that, this econ prompt down here at the L5 position will be used to go back to econ speed. So once he says, okay, disregard the 290, you can go back to normal speed. We can just line select that econ speed, execute, and it'll go back to our econ cruise speed then. So again, there's usually two ways to do things. One through the mode control panel, two through the CDU. Just depends how you want to do it. Again, the pilot flying could do it through the mode control panel, or you could just tell the pilot monitoring, go ahead and put that 290 on the cruise page. And he'd say, how's that look? There's 290, looks good, execute. And of course, again, we talked, this is the way we did it last time. We opened the window, we brought the speed back, and then the title of the page changed to active MCP speed cruise. And remember, we said the page will tell you what you're controlling to. And right now the window's open, so we're controlling to the mode control panel. We're still in VNAV, but we're controlling the speed, not the computer. Resume normal speed, we just push the selector, blanks, goes back to active econ cruise, and the speed will go back to the econ cruise speed. And we're not going to do it that way. We're going to do it the CDU way because we did it this way last time. Let's go to this one's going to be, let's say we have a PAC problem and we get maybe a PAC 3 message. So we'll go to our P's. And we get PAC 1, 2, 3. We have PAC 3. So we'll go to 2.22 or whatever it was. And we have a PAC 3 message. We have a system fault light. May or may not be illuminated. The condition is one or more of these occur. A PAC controller fault, a PAC operation fault, a PAC overheat, or a Pack 2 shutdown and a cabin pressure relief valve is open. The objective is to attempt to switch to a functioning controller. Remember, on these packs, there's 3 packs, but there's 2 controllers for each pack. There's an A and a B controller for Pack 1, there's an A and a B controller for Pack 2, and there's an A and a B controller for Pack 3. So that if one controller doesn't work, you can switch to a different controller. So this procedure will have us making sure the trimmer switch is on, pack control selector number 3 to A. So we're coming out of our normal position and going to A. And then we're going to bring the pack reset switch push, and that's a momentary action switch. When we bring the pack control selector to A, that's a rotary switch. So we're going to bring it out of the normal and go to the A position. That's a rotary switch. But then when we push the pack reset switch, that's a momentary action switch. It'll go in, it'll come right back out. You want to make sure when you push these switches, if you were actually to do it, you have to kind of hold it in for just a half a second or so to make sure it makes contact. Sometimes guys will push these switches really fast. They'll go up there and poof. Their finger goes in and out real fast, and it may not trigger the condition that you want to trigger. So you have to kind of push and hold for just a half a second, then release it. That ensures that it's going to do what it's supposed to do. You can push these switches without it making, contact. You might push it like 80% or 90% of the way in, but it never really makes contact. I've seen people do that before. So we go pack control selector for number 3 to A, and then we push the pack reset switch. And then you've got a decision tree here. Choose one. Pack message blanks. You're good. End of procedure. End of checklist. The pack message stays shown or shows again. Then it says go to step 5. Pack control selector on number 3 to B. So now we're getting A didn't work. We tried to reset it. Didn't work. We're going to B now. Pack reset switch push. After we go to B, choose one. Pack message blanks. End of checklist. Or pack message stays shown or shows again. Pack control selector number 3 off. You basically checked both controllers, tried to change to another one, tried to reset the one, tried to reset the other. If it doesn't work, turn the pack off. Whatever's causing the condition, we couldn't reset it. So now the pack is inoperative at that point. So we'll do that procedure instead of that one. Okay, then after Pendleton, we're going to join J16 to J153 to Spokane. That's going to be the clearance. After Papa Delta Tango, J16, J153, Spokane. And when you hear 2 airways, one after the other, it's an airway crossing an airway. And that may or may not have a defined name. If it does not have a defined name, then the computer will create a crossing of those 2 airways. So if it does have a name, it'll pull up the name from the database. So all you're telling it is that after Pendleton, I want to go on J16 to intercept J153 to Spokane, Golf Echo Golf. So in order to put this in, after Pendleton, we're going to put J16 in, and it says J16 to where? Well, he didn't give us a waypoint. He just said J16 to J153. So right below this, we're going to put J153 in. And so when we put that in, the computer will look at its database and say, do I have a name for J16 crossing J153? And if it does have a name, if it's a named waypoint, it'll put that name in. If it doesn't, it's going to create a waypoint there. And it says XJ153. And that's the crossing of the J16 and J153, that XJ 153. And that'll define the crossing of that airway coming out of Pendleton, which is J16. And then J153 would be out of Spokane. And where those two cross, it would create a starting or a crossing point. Now you're going to notice in this case it did create a crossing point, but when we do it, it's a named waypoint actually now. Maybe at this time it wasn't. I think it still was, but this wouldn't give us the name. So when we do J16 and J153, it looks to the database and says, oh yeah, that's Chase waypoint. So it'll come up and say Chase here, Chase, Chase, because it has a name, the crossing of these two airways. So the computer can either pull up the name or create a point if you give it two airways like this. So that's another way to create a waypoint, is a waypoint of two crossing airways. And then, of course, you'd execute it with confirmation. And then when you execute it, it will look like this. Now, in our case, again, we're going to see Pendleton, Chase, Blunt, and then Spokane. And it'll say Chase here at R2. Then we already did this, I think. I think we did this early on, the EFIS control panel failure, so we probably won't do this. But again, just remember that anytime you get an EFIS control panel failure or an ICAS control panel failure, you're going to get select prompts in one right and two right. Again, this is the older method where you did not have the off and on ability to turn it off and on at will. The only way you would ever get into this is if you had this kind of failure, one or two of these, or both. If you have a failure of one or two of these, you're going to get select prompts on both of them. And then you can get into the EFIS control panel or ICAS control panel. And again, once you get in there, we said that everything you can do on the EFIS control panel, you can do through the CDU. Anything you can do on the ICAS control panel, you can do through the CDU. So if you remember, we did that back on, I think it was period, I think we did it back on period 1 or 2. Then we're going to do a cruise descent to flight level 230. So again, that's the same thing. Just spin the window down. 250 would be in here. Push it. It'll go to 230, and the title of the page will change to Active Econ Cruise Descent. And it'll descend at your cruise airspeed to your new cruise altitude, which is 23,000. Then we're going to be cleared for the ILS 21 with the Spokane transition. Then we're going to have a smoke, fire, or fumes problem. So let's go to the QRH, look at this. And remember, we said this was a quick action item. At the bottom, smoke, fire, fumes. So if we got a report, if somebody came back and said, there's some fumes in the crew rest area. I don't know where they're coming from, but I'm smelling something that smells like it's burning back there, but I don't see anything, and I don't see any smoke, but I do smell fumes. Okay, so we go to this smoke, fire, fumes procedure. Condition is smoke, fire, fumes occur. Diversion may be needed. Okay, you may want to divert right away. It depends what the situation is, and we find that it's more beneficial not to wait. If you're not sure, but start a diversion if you need to. It may be something that can be controlled. If it is, then you may not need to divert. But if you're not sure what's going on, they can't tell where the fumes or the fire or the smoke is coming from, you need to divert. Don the oxygen mask if needed. Well, if it's on the flight deck, we're going to get our masks on. If it's not affecting us yet, we don't have to, but we would later if we need to. Don the smoke goggles if needed. Well, most of the time, these units are all one unit now. So a lot of times these airplanes don't have smoke goggles anymore. Some may still, Some of the older ones may still, but the newer ones usually have, people have replaced these, or airlines have replaced these with a full face mask plus the oxygen. Establish crew communications, captain on oxygen, first officer on oxygen. Then on the freighter, instruct the supernumeraries to turn on the upper deck reading lights, because things may get dark. So they turn on the upper deck reading lights. Utility power switches both off, and flight deck fan switch off. Make sure the flight deck fan switch is off. It probably should be. And the utility power switches are coming off. Now, why is that? Well, those are the big draw items. You know, they're big electrical draw items. And utility power switches can have galleys on them. They can have the bigger stuff that could cause like smoke or fire. You know, so we're turning those off, and you know that could solve our problem right there. APU selector off, supernumerary signs on, and notice it says in number 10 here, anytime the smoke or fumes become the greatest threat, then go to the smoke or fumes removal checklist. There's really two checklists here. There's a smoke, fire, fumes checklist, and there's a smoke or fumes removal checklist. We don't have to start removing it right away, but if it becomes unbearable, starts to become really thick, and you're getting reports to that, then you may want to go to that smoke or fumes removal checklist and then come back to the smoke, fire, fumes checklist, because we got to try to remove it, so people can breathe. And then you'll notice it says choose one. So now we've got several decision trees coming up. The source of the smoke, fire, fumes is obvious and can be extinguished quickly. Or the source of the smoke, fire, fumes is not obvious or cannot be extinguished quickly. So which is it? Is it if it's obvious and we can, if it's a little fire in the lab and we put it out, that's one thing. If it's smoke that's becoming thicker, but we don't really see where it's coming from, that's another thing. So in this case, we don't know where it's coming from. He just said there's fumes in the back and in the crew rest area, but he's not sure where it's coming from, and he doesn't see any smoke. Okay, so that would be the source of the smoke, fire, fumes is not obvious or cannot be extinguished quickly. Go to step 13. So we'll go to step 13. Now notice step 12 is if it was obvious. Then step 12 is continue the flight at captain's discretion, restore unpowered items at the captain's discretion, and we're assuming that the smoke or fumes are decreasing. And we visually confirmed that we've extinguished or fumes are decreasing. So in that case, yeah, you might be able to continue if that's the case. But again, I'd be real leery of continuing unless, things can start up again. Smoke is not visually confirmed. Go to step 13. And then 13 says, divert to the nearest suitable airport while continuing the checklist. So we devise ATC, we declare Mayday. PAN would get you, if you did a PAN, that would get you assistance, and it could develop into a Mayday. So you could elect to do a PAN initially, and then, but if it quickly becomes a Mayday, then do a Mayday. But this would warrant a Mayday if you need to do a Mayday. But you could also do a PAN, and that's kind of we need immediate attention, and then it could turn into a Mayday if it gets worse. So consider an immediate landing if the smoke, fire, fumes situation becomes uncontrollable. Do not delay the landing and attempt to complete the following steps. Isolation valve switches both off. So you turn off both isolation valve switches on the pneumatic panel, and that will isolate the left and the right sides of the bleed air system. And we also turn Pack 2 control selector off. You've isolated Pack 1, Pack 2, and Pack 3. But now that you've isolated Pack 2, we're going to turn that off. And then we're going to see if that's the culprit. maybe that's the problem. Maybe it's pack 2. So wait 2 minutes unless the smoke or fumes are increasing. This allows time for the smoke or fumes to clear. So we'd start our clock for 2 minutes. After 2 minutes, we go ahead and then see if it's still continuing, if it's decreased, what's the status. If they're increasing, we don't necessarily wait the 2 minutes. So choose one after the 2 minutes or if they're increasing. Smoke or fumes continue or are increasing. Pack 3 control selector off. And then we're going to wait 2 minutes again unless the smoke or fumes are increasing. This allows time for the smoke or fumes to clear. So now we've turned off 2, now we've turned off 3, and we've left pack 1 on. And so we're checking, we didn't think it's 2, that didn't seem to do anything. So now we're checking, let's check that if 3 is the culprit. And then it says go to step 20. And after the 2 minutes, or if they're increasing, we choose one. Smoke or fumes continue or are increasing. And let's say they are. We still smell the fumes. They haven't gotten any worse, but we still smell the fumes. Pack 3 control selector normal. Pack 1 control selector off. Isolation valve switch, right isolation valve switch on. You're still isolating pack 2. But you're bringing pack 3 back to normal, so you have a pack on. And then you're opening the isolation valve. And it looks like pack 2 is still shut off. But we've got pack 1 isolated now, basically, because we think the problem may be in pack 1 now. So it says, and now we go to step 21 after that. And then we can bring pack 2 control selector back to normal. So that was, off, but now we're bringing that back to normal. So now we've got 2 packs on. And we've got the pack 1 isolated, basically, and we're seeing if that's the problem. So it says wait 2 minutes unless the smoke or fumes are increasing. This allows time for the smoke or fumes to clear. Okay, and then after 2 minutes, or if they're increasing, are the smoke or fumes continue, or are they increasing, or are they decreasing? If they're still increasing, or they continue, then we're going to bring the isolation valve switches both on, the pack 1 control selector back to normal, and then we'll consider an immediate landing because none of that worked. If they're decreasing, we can go to step 24 then. And step 24 says just do not accomplish the following checklist. Cargo detector error, electric utility bus left and right, fuel override 2-3 forward, fuel pressure center left, fuel pump 2 and 3 forward, temperature zone, trim air off. Any of those messages, we don't have to accomplish the checklist. They're just part of the condition of the steps we've taken here in the smoke, fire, fumes. Now, if, again, and you'll notice the last step here is go to the smoke or fumes removal checklist if needed. And again, we could have done that any time if the condition was getting bad and we needed to remove, we'd go to that. But at the end of the checklist, we are going to go to that if it's still happening. So we'd go to the smoke or fumes removal. Let's see where that is. Again, if I wanted to look that up, the easy way to do that is, and you notice it's not here, and it's not really an ICAS message. So we'd go to the unenunciated, and we'd look up smoke or fumes removal. That's in the unenunciated. So it's probably the second one here, yeah. So this says smoke or fumes removal. Condition: smoke or fumes removal is needed. Objective: to remove smoke or fumes through the smoke override valve or the smoke evacuation port. Do this checklist only when directed by the smoke, fire, or fumes checklist. Do not delay landing in an attempt to complete the following steps. We're going to bring the equipment cooling selector to override. That creates a differential flow through the smoke override valve on the left side. there's a little port that will, all the fans will turn off, and the valves will redirect the air through the smoke override valve on the left side. And then it says choose one. Well, we got three conditions here. If the smoke or fumes does not persist and is not severe, we'll go back to this checklist if you haven't finished it. But if the smoke or fumes persist or are severe, and the smoke or fumes is on the flight deck, then we're going to do this. We're going to pull the smoke evacuation handle, blah, blah, blah. You can read that. The third condition is if the smoke or fumes persist or is severe and the smoke or fume source is determined to be in the cabin, then we're going to go to step 5 and we're going to do all this. So the conditions are, it's getting better. Okay, go back to the checklist. Maybe the checklist is done, then you don't need to do anything because it's not getting worse. If it is getting worse and it's on the flight deck, we're going to do this. If it's back in the cabin, we're going to go do this. And this would be to bring the landing altitude switch to manual. Set the landing altitude selector between 8,000 and 8,500 to command the cabin altitude to 8,000. Bringing the cabin up will increase the airflow and hopefully, take any smoke out with it through the outflow valve. And bring the equipment cooling selector back to normal. Start a descent, level off at the lowest safe altitude or 8,500 feet, whichever is higher. Once you're down, outflow valves both on, go to manual, and then outflow valve manual control, open the outflow valves. So you're completely depressurized now. And then do not accomplish the following checklist: cabin altitude auto, landing altitude, outflow valve left and right, and then you're landing, obviously. So again, there's two things there. There's the smoke, fire, fumes checklist, and there's the smoke or fumes removal checklist. But we always go to the smoke, fire, fumes checklist first. Then if we need to, we go to the smoke or fumes removal checklist if it's getting bad that we need to do something to try to get smoke or fire with smoke or fumes, bad fumes, out. And that's what we're trying to do with the removal checklist. And then we go back to the smoke, fire, or fumes checklist once we finish that if we need to. So we'll run through a scenario there where it's kind of involved, so we do a lot of these steps. Obviously, you could end it soon if you just did a few steps and it worked. If you just turned the utility buses off and it worked. Okay, there's a problem in one of the buses or the galley, or something's not right there, but we don't have any fumes anymore, any smoke anymore. That solved the problem. I mean, then you wouldn't have to go through the rest of this. But it just depends what's happening with the smoke or the fire or the fumes. Okay, then we're going to go for the ILS 2-1 with the Spokane transition. These waypoints may not be the same. I can't remember. And these altitudes may not be the same. But we're going to do the full procedure. That's going into Spokane, out for course reversal. And I think the course reversal in this case, I don't know if it might be a holding pattern for course reversal instead of a procedure turn. I think. I don't know. We'll take a look at it. In any event, if it's a holding pattern, the purpose of that holding pattern is to reverse course. If it's a procedure turn, well, it's definitely to reverse course. If it's a procedure hold, it'll say procedure hold. And what that means is that it can it'll go out on whatever the holding pattern entry is, come back in, and then when it hits the fix, it'll go to the next fix automatically. You do not have to exit hold. It's a procedure hold, so it's not going to hold there. It's just doing it for course reversal. And once it hits the fix, it'll go to the next fix after that. You don't need to exit the hold. This is just showing we're above the VNAV path. We showed that last time. If we put an altitude in it, maybe they put 4,000 at Fort here, crossing Fort at 4,000. that made us high on the path, and then we could increase the speed or use speed brakes or a combination of both to get down and get on the path. Here's our speed deceleration circles on the ND, the 2 circles, the start of deceleration, the end of deceleration. I remember approaching the procedure turn or procedure hold. I'm not sure which one it is. We'll see. Then we want to be, slow down. Obviously, when we're in this segment where we hit Spokane and turn, we want to be at 200 knots or less. In this case, you can see we're at flaps 5, speed 185, and we're Fort outbound for the procedure turn. And again, we're still in VNAV. Procedure turn inbound would be when we intercept just about when we intercept the course inbound. That would be procedure turn inbound, not when you complete the turn, not when you're out here. If you're out at still on the procedure turn, that's not procedure turn inbound. It would be when you intercept the course inbound. If you're within, very close to the course inbound, you could report procedure turn inbound. And then from there, we're going to do the ILS approach. No different there. We'll do the landing checklist. When we get to minimums, nothing's going to be in sight, so we're going to go around. The go around would be to push the either one of the go around switches. The go around switches are on this airplane are co-located with the takeoff switches. So those are toga switches. So you've got the 2 toga switches on the front side of the thrust levers. The left toga switch would be for the captain when he's got his right hand on the thrust levers. His right index finger can push the left switch. For the first officer, it would be the right toga switch, which would be the FO's left hand and his left index finger pushing the right toga switch. Either toga switch will activate the go-around, or both, but we generally don't want to push both. You push one or the other. You want to give it a full push. Again, you're going to have this as simmers, virtual pilots. We're going to have we're going to have a button for this, right, to go around. So we don't, actually have the feel of the thrust levers here, but you can push the toga switch, and if you don't push it fully, you won't get the go around mode. So this is another switch where you got to, like the momentary action switch, you got to push it all the way down, give it a good solid push, and then the thrust levers will start to advance. You're going to see thrust toga on the PFD like you see here. The thrust indicates that it's a variable thrust, and it is a variable thrust. Initially, it goes to full go-around thrust, and then when you get 2,000 feet a minute climb rate, the power will actually retard to keep you at 2,000 feet, and that's kind of a derated go-around. If you don't want that, you could always push the toga switch a second time, and that would remove the derate, and now we'd go to full go-around thrust. But generally, 2,000 feet a minute is sufficient in a go-around. And that's why it says thrust. It doesn't say thrust reference. It says thrust because thrust is a variable thrust. Remember, we saw that with flight level change. And variable means at 2,000 feet a minute, and then the power will actually come back to keep you at 2,000 feet a minute. And then, of course, after we push the toga switch, the thrust levers will start to advance, and then we're going to call for go-around thrust after we push the toga switch. Flaps 20. The pilot monitoring will give us flaps 20. He'll say positive rate, then you'll say gear up as the pilot flying. And that's kind of the first step of the missed approach procedure. And you can think of it as configuration. We have to configure. So the configuration is we've got go-around thrust, we've got flaps 20, positive rate, gear up. So now we're in a better situation to climb. The next thing, you kind of think of this as 3 steps. That's the first step. The second step is at 400 feet, we're going to go to a roll mode. And the roll mode is going to be LNAV or heading select, depending on what ATC wants you to do. If they don't say anything, they want you to carry out the published missed approach procedure. If they say something, they're probably going to give us a heading. In that case, it'd be heading select. But in the case of nothing said, then we carry out the published missed approach, and we'd go to LNAV. Some 400s, I think, have auto LNAV, but a lot of them do not. We'll talk about auto LNAV with the Dash 8. But most of the 400s, just you have to go to LNAV at 400 feet. And you can see we've done that here. We've gone to LNAV. So we've got the, notice on the vertical rate here, we have 2,000 feet a minute. Notice thrust, LNAV, toga. The roll mode is in LNAV. The pitch mode is in toga. And so toga is basically pitching to maintain your reference speed right now. But we're going to change that when we get to 1,000 feet, because that's where we want to accelerate. If that's where you want to accelerate. Sometimes you could wait till higher if you're not sure of terrain. You could always wait till you're above a minimum sector altitude, but generally we're going to start accelerating at 1,000 feet. And so the next step would be to go to our pitch mode at 1,000 feet or higher. I probably could have put or higher in there. You could always stay in this configuration until you're higher and you feel like you want to accelerate. And then your choice is either VNAV or flight level change. In this case, we're going to VNAV on the first case here. And notice the pitch enunciation is it would go to VNAV speed initially, and then it's going to level off and capture the 4,000 in this case and go to VNAV path. And that only because we have 4,000 in here on the legs page going to Spokane. So VNAV, the window will blank, the speed will automatically go up, and then we're going to retract flaps on schedule. So we'd go flaps 10, flaps 5, flaps 1, flaps up. If we want to go all the way to flaps up. And now this is our choice too. Is ATC, what are they going to do with us? Are we going to go the holding pattern? Are we going to be on vectors? You know, depending on what they're going to do. If I'm going to a holding pattern like this, like you see here, I'm probably going to want to stop at flaps 5 and 200 knots. I could go flaps up and then stay at a speed higher than 200, but then I got to tell ATC, hey, we're requesting 235 knots in the hold. And he'd have to approve it because the max holding speed is 200 knots below 6,000 feet. So as long as you're going to a holding pattern, we could either elect to retract the flaps totally and then request a higher speed in the hold, or we could stop the speed. We could speed intervene here, push the knob, bring the speed back to flap 5 speed, and then just go flaps 10, flaps 5, and stay at flaps 5. And then enter the hold at 200 knots. Then we wouldn't have to tell them anything. So there's kind of choices to be made here, whether you want to keep the window blank, open the window, do you want to stay at flaps 5, or do you want to go to flaps up? The other case is that we use flight level change. And flight level change would always come with the speed. So we just don't go flight level change, we have to bug the speed up. When you push flight level change, it's going to go to your target speed, and then we need to increase the speed up to whatever we want. So in the case of, let's say I'm going to the hold again, and I want to use flight level change, I would, at 1,000 feet, I'd say, again, if the autopilot's engaged, I can do it myself, if I'm pilot flying. If I'm still hand flying the airplane, I would say, give me flight level change, speed 200, and then that's it. And then retract the flaps, flaps 10, flaps 5, and then we'll level off and we do the after takeoff checklist. And we keep the flaps at 5 and enter the holding pattern. If you wanted to retract them fully, we could go flight level change, speed 250, flaps 10, flaps 5, flaps 1, flaps up, and then do our after takeoff checklist. Again, we're probably going to limit the speed if we're going to go back and land. Maybe he starts giving us vectors back to land. We may not want to retract the flaps fully. We may want to stay at flaps 1. So those are the three parts of the go-around. Think configure, 400 feet, 1,000 feet. Configure, go-around thrust, flaps 20, positive rate gear up. 400 feet, heading selector LNAV. 1,000 feet, VNAV, or flight level change, speed, blah, 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 whatever you want. But again, with flight level change, we always got to, the computer's not going to set the speed. We have to set the speed. In VNAV, the speed will go up to your flap retract speed minus 5 knots. So we're going to go ahead and just continue to retract the flaps unless we intervene on this. In this case, you can see the missed approaches from flight level change. The missed approach is captured. If we go from thrust, flight level change speed to speed alt, and the airplane will level off at 4,000 feet. And now we're out of toga for roll. We're out of toga for pitch. The auto throttle's in the speed mode. We're completely out of the go-around mode. But again, generally we can start cleaning up at 1,000 feet if it's safe to do that via terrain. If there's any question on terrain, then you can wait till you're higher. But generally 1,000 feet is normally fine in most cases to start accelerating and cleaning up. Then it'll be vectored back around for an ILS runway 21. We'll get, we're not going to hold, so we'll get vectors back. And then we'll reset up for the ILS, depart, legs, navrad, and nitref. So make sure your auto brakes are still set. Technique, sometimes on a go-around, I always use this technique if I went around. My hand would always stow the speed brake because the speed brake was armed for landing. There's nothing that says you have to do that. You could leave it armed, but I'll stow it generally as part of the go-around. And then on the ILS approach next time, we'll go ahead and arm it again. So then we do the ILS runway 21, and then that's to an auto land, and then we go for our shutdown and secure.